Let me ask you something important. Do you think you're getting enough protein, or do you actually know? Because most women I work with believe that they are. They eat clean, they prioritize food quality, they don't skip meals, but their labs quietly tell a different story long before symptoms show up. And that's the part no one explains. Your blood work can reveal protein insufficiency before you ever feel it. You just haven't been shown how to read it. Before we dive in, there are 3 important things that you need to hear. First, no single lab tells the story by itself. The more the markers that you have that are low or trending low, the greater the likelihood that your body is going to need more protein or total fuel. Second, I'm going to provide you optimal ranges on the screen for the markers that I'm going to discuss. These are the ranges that I personally use. They're not the same ones that your doctor uses, and they're not the broader disease-oriented ranges that you're likely to see on your current lab report. And third, I am a doctor, but I'm not your doctor. And I don't know your medical history, your medications, or your unique situation. What I'm giving you today is simply education, a perspective, and a tool. It's not meant to be a diagnosis. Now, here's the bigger picture. If your body isn't getting enough protein, it's going to show up system-wide. And labs, they reflect that long before any type of disease or dysfunction appears. So let's walk through the 8 markers that matter the most to evaluate your protein. BUN, blood urea nitrogen. This is going to reflect your nitrogen disposal from protein metabolism. Essentially, how are you getting rid of the breakdown product of the protein that you're consuming? If it's chronically low or low normal BUN, that can suggest that you have low protein intake or low total calorie intake. One of the things to consider here is that there's often an assumption that low BUN is good, that it reflects or it's only a reflection of kidney health. But low BUN is not automatically good, especially not when it's tied to protein intake. Creatinine. This one often goes hand in hand with BUN, and they're often both looked at as it relates to kidney function. But creatinine is going to be reflective of your muscle mass and your creatine turnover. So we want to not confuse creatine and creatinine. But the more muscle you have, the more storage capacity you have for creatine and what's also known as phosphocreatine. Creatinine is a breakdown product from creatine and phosphocreatine. The lower your muscle mass, often lower your creatine levels are going to be, which is going to translate into creatinine, lower creatinine. Your lower creatinine is often going to signal that there's an insufficiency in muscle mass in the body, that your anabolic or your rebuilding, your regenerative ability, that's going to be lower as well. And also that there is an association with lower animal protein intake in the diet. And this is especially important for women as they age. I really need to address this assumption, though, that a high creatinine is associated with kidney dysfunction. That needs context. This cannot be looked at universally the same. Creatine is not a kidney-only, or creatinine is not a kidney-only marker. It's meant to give you an idea in the context of possible kidney dysfunction, but it's not always pointing to kidney dysfunction. In fact, creatine supplementation has been shown to not be aligned with kidney dysfunction. So creatinine alone, it's never going to be enough as far as a marker to look at to judge this kidney component. If you want to understand if there's possible dysfunction as it relates to your kidneys, then you would expect that there's going to be a rising creatinine, and you would also see that what's called your glomerular filtration rate, that would be declining. But there's other markers that need to be a part of this conversation as well, like cystatin C or microalbumin. If the microalbumin is elevating, maybe there is a problem there. But all of these need to be looked at in context and not a decision only made based on BUN or creatinine levels. And the other thing is, what's the trend here over time? That's equally important. Remember, just like I said, one marker by itself doesn't tell the full story. One lab test is simply a point in time. It doesn't tell the trends or the continuum for your health over time. So if creatinine is mildly elevated in isolation, then kidney disease, kidney dysfunction, that is definitely not proven, and that is not the direction you want to be looking. So I'm not going to continue to talk about these other sort of assumptions, but that one is such a big one that I needed to tackle that one and make sure that you don't get led astray with that one. The next marker we'll look at here is going to be total protein. This is a combination of albumin and globulin, but it's not directly telling you about dietary protein. It's not a measure of dietary protein and how much protein you're directly consuming or not. It's more of a reflection of protein availability and utilization. So when you have a low normal protein, that's going to be suggesting that you're likely underfueling your body. You're not getting enough total calories in, especially the protein component, that you may have poor protein intake, right? So just not meeting what your needs are on a day-to-day basis. Or it may also point to the fact that your absorption and utilization of that protein is not good either. There's also the possibility that it could be implying that your liver function is suboptimal as well. And when you see that there are shifts and low trends in total protein, especially if this has been going on for any length of time, you also want to think about chronic inflammation or some type of overactivation of the immune system. Now, just like total protein can be beneficial in helping us understand if you're meeting your requirements or not, the breakdown products of the protein, of total protein, albumin and globulin, can also be helpful here. Let's start with albumin. Albumin is a long-term indicator of protein status. It's going to have what's called a half-life of about 18 to 21 days. So meaning that its useful lifespan is going to be about 18 to 21 days. It can show a pattern of low intake, but it's also, in doing so, it's not reflecting day to day or likely not even reflecting changes over a given week. Remember, this is long term. It's 18 to 21 days. This is going to give you more of an idea of how things are if your protein requirements are being met over months, not just simply a shorter time frame. So this one can be extremely helpful for you. When you see that your production declines in favor of your survival needs, so for example, if you're seeing your albumin levels are dropping and they're doing so because your body's feeling the stress of immune challenges because your energy requirements have changed, or just your environmental stress around you has increased, you really need to be keeping an eye on your albumin. And if that albumin's dropping, your protein levels need to increase in your diet. Low normal trends matter with albumin more than a single result on a single lab test. If this video is already making you look at your labs differently, go ahead and hit that like and subscribe button, and drop a comment if you've ever been told that your labs were normal even though you knew something wasn't right. If we haven't met, I'm Dr. Arland Hill. I'm a clinician and I'm a rancher, and that allows me to see both sides, the physiology and the food. And when you understand how food interacts with your biology, that's going to clear up a lot of confusion, including if you're getting enough protein or not. The other half of total protein is going to be globulin. Now, globulin is going to be tied to your immune system. It's going to be reflective of the protein production in your immune system. When you have a low globulin level, that can signal that there's an inadequate amino acid availability. Those amino acids are the breakdown products of proteins. It could also mean that there is suppressed immune system protein synthesis, that you're not making the proteins as readily as you need to. And that could be a byproduct of some type of long-standing chronic immune function. If that happens, these are all triggers that it's not just about your total intake here. You need to be thinking about how your immune system is demanding more protein and making sure that you're getting enough of that protein in. And it's also important because this is an illustration that just keeping some type of dietary log is not going to be adequate here. You really want to know if that protein that you're taking in is meeting the marks that it needs to change your physiology and change the way your body functions. And what better way to see that than through your immune system, which has to be on guard all the time. Before we leave the albumin and globulin of total protein here, the last one that we need to look at is the albumin-globulin ratio. And this is going to show the balance between these two proteins. In fact, it's comparing two competing protein priorities. You're comparing the structural proteins in the body versus the immune system proteins in the body. Albumin, that's going to be your structural protein. It's needed for transport. It's needed to be able to mobilize nutrients in the body to deliver those, and it's an indication for long-term stability. In contrast, globulin is giving us an indication about the immune activity, as I shared with you, and how that's translating to inflammation and your antibody production. But this is more of a stress response. So you have this difference between, is the protein being used from a long-term health building perspective, or am I using proteins for more of an acute stress response type of response in the body, and how do I help balance that? This will help you see patterns. Again, this is not about trying to diagnose anything. This is completely contextual. This allows you to ask the question, is the body prioritizing building and maintaining tissue, or is it prioritizing fighting and reacting? The closer that ratio is to 1, the more of a problem this is. The reason that this ratio is so important is because you can still have a normal albumin and globulin, but still have a problematic ratio that tells you about the bigger picture. Moving away from total protein, albumin, and globulin, that leads us over to alkaline phosphatase. And alkaline phosphatase is an enzyme. To optimally function, that enzyme requires adequate protein, zinc, and phosphorus. If you have a chronically low alkaline phosphatase, which is very common, this is going to often be a signal for undernutrition or low anabolic activity, low building and regenerative ability. This is one of the most overlooked protein clues, and it's one that I often lean on because I often think that when I see a low alkaline phosphatase, that tells me that zinc is a problem, and then I start asking, where does zinc come from in the diet? It comes from protein sources most of the time. That's where the most available sources are. If I just start tracing this backwards, it can lead me to the fact that someone is not consuming enough protein, or they're not utilizing the protein that they are taking in. Most of the time, alkaline phosphatase is only viewed when it's high. That's really the only time that a lot of comment is made about that. Maybe it's pointing to gut dysfunction or liver dysfunction or bone concerns, but a low alkaline phosphatase can equally provide relevant information, especially if we're trying to figure out if there's enough dietary protein coming in or not. Phosphorus. This is one that is required for energy production, what's often known as our ATP. That P in there is going to be tied to the phosphorus. It's indicative of protein synthesis because phosphorus is a component of protein synthesis. It's literally structurally tied to protein-rich foods. So think about your phosphorus is such a good indicator because phosphorus travels with proteins. This is really true when you talk about animal-based foods where the protein is where energy production has to be taking place at, or where it's important to have these energy molecules. That phosphorus is going to be core to the muscle. It's core to the cell membranes because it's producing what are known as phospholipids. So phosphorus, you'll see the tie in there. And even your DNA and RNA are going to require adequate amounts of phosphorus as well. When you have low or low normal phosphorus, that's often going to reflect that there's an inadequate protein intake, or maybe that the total calories that someone is consuming is not adequate either. And here again is a marker where we can see a misinterpretation take place. That misinterpretation is often that high phosphorus is associated with kidney dysfunction. Remember, it's not. It's giving you an idea about if you're getting in enough total protein, or it can give you an idea if you're getting in enough total protein, and animal-based proteins are especially important to this conversation. Now, if you're looking for optimal sources of animal-based proteins, make sure you check out Harvest Hills Ranch, where grass-fed and finished beef and pasture-raised poultry, that's all we do, guys. That's the norm. We raise it right here at Harvest Hills Ranch. I want to leave you with a few additional markers that can be reinforcing clues. These are going to be brief comments here, but I think that these are important because these may be the indicators that say, yep, that in totality, along with the other things I've seen, that's giving me the clue that yes, I'm not getting enough dietary protein. So one is that if you have very low triglycerides, this can often be an indication of overall low energy intake. You're probably just not consuming enough calories total, and protein certainly would be a part of that. Another indicator here can be if you have patterns of low blood sugar, what we often call hypoglycemia. That can be seen with low glucose, low hemoglobin A1C, low C-peptide, low insulin. These can all point in that same direction as well. These are indicators that you're under fueling. When your calories are too low, protein insufficiency almost is always part of that conversation. It's rare that protein sufficiency is going to happen in light of not consuming enough total calories. Here's how you're going to use this information. This is not about fixating on a single number. Patterns are always going to be more important when it comes to reading labs than any one lab marker is going to be. It's about recognizing that pattern because that pattern is telling you that many times your body needs more fuel and more protein. You don't need to track macros or grams anymore. What you need to do is look at your labs together, notice the trends, and stop assuming that normal equates to optimal. When you read your labs in context, they stop being confusing and start becoming instructive. They tell you whether your body is being adequately fueled or quietly running short of what it actually needs. And if you want to understand which protein sources actually support what your labs are reflecting, well, go ahead and watch this video, Chicken versus Beef, the nutrients you're not hearing about.